Hello, welcome back. This is lesson number 7 of this Introduction to Computer course, and it is about the network communication and the connectivity. So this lesson has a lot of technical terms, and we are talking a lot of hardware in this chapter. Then connectivity or usage of this network devices for our personal use. So this one is more of a software component of the connectivity. So you need the equipment, that's the hardware part. So that's what we will look at first. Okay, so the coverage wise that there are many different type of networking. So we'll define the meaning of the network, and then there are different varieties. Some of them are very they're old. Old means that being here very long time. Some of them are very recent development, especially closer range. Because of this fourth generation industrial revolution, try to connect almost everything, super connectivity, so connect everything, including our body cell into some kind of communication. So that classification, we'll look at it, and that including recent developments. Then there is the telephone or mobile, the phone. I'm sure all of you own one and using it every day, and you cannot part with it even a single moment. So we'll look at some of those mobile phone issues, and you hear about 3G, 4G, and talking about 5G, the cell phone, so what it is all about. Then we'll talk about the internet-based communication methodologies. And then of this, there are many varieties that in chapter the 8 talks about, but the one thing I'm going to talk about is about the email part. Okay, so let's see. So what is network? So I have some picture of a net. Well, when you are playing this volleyball or go to fishing, then there's a net. Net is the kind of a grid with a lot of hole, but nevertheless, that so suppose the air and the water passes through, but there is a overall structure, and then each node is a connection, the point. So each point is somehow connected to neighboring points. That connectivity, that's what look like a net. So they wanted, say, web. Actually, when we say the website, that web is from the cobweb or those spiders web, because it's the all less the regular form than this typical net. But anyway, the network is intended for having this kind of the structure where there are a whole bunch of dots and they are connected. That each dot is a computer and a site, one cell phone, like that. So from the net of connection of all members. Then the application to so many situations, including human relationships. So when you go out and join a club or some kind of association, then you want to do networking. So networking means that meeting each other and some kind of a connection or communication personally and in group. So that's the very frequent terminology we are using, that so-called network or networking. So in fact, there are so many usage of the word net or network or networking. So when we are talking about this network, actually what it means is communication network, or that even this can be a little misleading, but because communication can be communicating between human beings. So actually this is the computer communication network, some people call it, or computer network, or sometimes it is called the node network. This harder than them. Node network means that there are individual computing facilities somehow connected. Then, so the super connectivity of a fourth generation industrial revolution that promotes and that mandates the capability of connection on every possible scale and every possible range. So earlier form of network is a wired telephone network. So I don't know whether you remember that, but there's a good old days, there's a wired telephone and the people are talking over the phone. That's all there was. So that time, it is the need to be connected. So suppose there are 4,000 people in a small city or in a campus, they want to talk. So we have the person 1, 2, 3, 4 to 4,000, and this person wants to talk to people, and the other person wants to talk to people. Sometimes the 3-way, sometimes the 4-way, but in general by pair. In the case they need some kind of a way of connecting. So here was a so-called circuit switch. So here, circuit means connection of a power or the electricity. So it is more like there's a central station, usually called the switch station, that had the whole bunch of holes. So in this example, 4,000 holes. That's too many. That's why you need many people. And then like this person wants to talk to somebody else. So each one had a line coming out of it, and say, okay, person number 14 wants to talk to the person whose number is 318. Then whoever comes first, those line will be going into and those slot, and they will plug it in, or the other way around. Then the in a sense, a simple diagram of a person 1, person 2, or person 14 and 318, somehow their line is connected. That's called the circuit switching, and they use the wire connection. It's more like a direct current going together with a connection made. But as time goes on, everything goes in computerized, and everything is digital plus that wireless, and we want to have more convenience. Some message may be very long, some may be short. So for the people who worked very hard to get best, more efficient way of making this kind of connection possible. So to do that, what they decided was so-called the packet. Packet is just like a little parcel. So think about this way. Suppose that you are expecting big package of your furniture or some appliance, or matter of fact, the book may be a good the example. So you got a 1,000 page, 2,000 page long book. In the case, one way is that they bring whole 1,000 or 10,000 page book directly to you, but that's inefficient. Sometimes too heavy, sometimes difficult. So they will cut into small pieces. That small pieces has some amount of data here, and not only that, there's a header that have some the information about the sender, receiver, and the packet number. So your book or your information is a long line, just like this, a long a series of paper or a strip of paper. Then okay, send this one first, and then send the next, like in that order. Then in the middle of the connection, some may arrive late, some may arrive a little early. The way you send, it won't arrive exactly in that order. So once you get it, you're getting. So when you're sending big data, like sending pictures or some the video especially, then usually takes time. So why it is taking time is that sending takes in a packet and sending in multiple packages. And when you receive, then your computer receive that one and temporarily store in a place called the buffer. Buffer is a temporary the storage location, and then they are sorting it out. So because of that header, each packet has a header saying that it is coming from, and then what is the packet number, obviously. Good thing about the data is that it's unlike the parcel of furniture or some appliance, that they are all same, just the bits, the data, so it's bits and bytes. So you can put into fixed size of those data, so it's called the datagram actually, and then there's a header, so you can put it in. So at a given day that you may get 100 email, then there's all different kinds. So some of them coming from your friend Joe, some comes from the Adam, whatever like that. So the sender and your receiver, and then there is a time stamp, and then the packet number. So it is reconstructing those things. So for example, for whatever reason, one package, one set of the email takes too long because the data is too big. It may take a while because it is waiting to the last packet to coming in. The last packet is not necessarily the last packet of the actual data, but it may be middle one, but just happens to be going around and arrive late. So whatever the case, computer can do this sorting, refitting, and then constructing back into one set of data and present to you as an email or as your message. So it is a lot of work, but it is kind of an interesting and efficient way of doing communication. So there are many ways of this the network. Typical network, the classification is go by distances. So when you're sending it, first that the electronic and all of them are electronic, and some are circuited with the wired, some of them are wireless, some goes on the air, some goes on the cable. So there may be differences in terms of the speed and the range, how far it can go. If it is going wireless, suppose from your cell phone, you don't expect that your cell phone directly connects the wirelessly to a person in, say, New York from Los Angeles. So there got to be differences in terms of those ranges. So a closer one is that near one is called the LAN, local area. Local area is local in a sense of a residence. So within house or within building, within a certain the community, that's the kind of LAN. So LAN is the closest one, and the wireless the connection, like your Wi-Fi connection, is also the LAN. So it's if you have internet in your house, then that is typically the one house. So it is house area network is the HAN, and then data storage, that there's a certain location only data got pulled in and pulled out like that. That is that data storage. So storage area network, just serving as a storage. So sometimes it's called the storage server. So that kind of a networking. So there's a few names like this. So when you hear about something AN, that's it's an area network, and it's all those HAN, SAN, WLAN, and then CAN, campus area network. Those things are all belonging to small area of local. Then if there is the networking is all connected together. So what I'm saying is that in here, in the campus area network, then every equipment, of course that is a connected equipment, will be directly communicable by direct connection. without relaying or going on other place. That's the area. So in one network, everything is one family. On the other hand, that you want to make it bigger, so much faster within a city and all in one family. That is called the Metropolitan Area Network, or MAN. And then wide area network. This is a more general term, so it's a wide area. Just like some people just they classify as a LAN and WAN only, and anything that is up to MAN, they usually say as a LAN, and then WAN and the internet that is called WAN. So wide area, like a whole country or the state within America, that kind of a much larger area. Then of course, why you need a different one? Because of the range and the coverage area is so big that you need a very special equipment, you need a special software to handle those large volume of traffic. Then internet area network. You may not hear about, you heard about internet, but you didn't really hear as an area network, but that's a EAN. It's a worldwide network. So internet is short for international, so whole world even. Actually, there is a interplanetary area network that exists, but it is not within the reach of most of people, so I didn't list it. But planetary area network means that if someday that we got to establish connection between Mars, Venus, Moon, and Saturn, like that kind of interplanetary, then it is a much wider area. It takes at least 10 minutes or sometimes an hour to get the signal go in and out, even if that the wave or signal moves with the speed of the light, but it takes a while to get communication. And also that while we are doing it, it will take a huge amount of data to go through. So it takes some kind of a special methodology. That methodology or convention of connection, or the way, the rule to make this packet and the store and recognize those things is called the protocol. I'll talk about the protocol in a minute. And then so then there by the transmission medium, there are phone line. Old days it was all phone line they used for the connection. So not only this is used for the voice, but also it is used for internet connection. Even these days, you heard about the DSL. This kind of connection is actually using telephone line. And when you look at the telephone line, then there are two pairs. So usually red and the blue, or white and the blue, or red, different colors, but it's a pairs around in here. So twisted pair lines, TP, the connection. So connection medium, how you are connected, is copper, usually copper line with some kind of a shielding. Then cable network is a coaxial cable. So a couple of pages later, I'll show some pictures of. Then much faster is optical. So it's more like a glass or a plastic, but the light is moving around as sending or receiving data. Then microwave. So microwave is more like a dish. So it uses very high or very the small spectrum or the wavelength, the wave to interchange or the exchange the data. So that's microwave. And then satellite. Satellite goes way up in the sky and they're communicating. So we'll look at that one in a minute. Then infrared is also used in the communication. Infrared, but this one doesn't go very far. So within a range of a small area or a small distance, that it can have an infrared light. So let's look at those closer range thing. So here, the modern day communication becomes more personalized and close range connection. And you heard about the Bluetooth, yeah. So our teeth is blue. Yes, that's the kind of name. In fact, the Bluetooth is a name of the king, Scandinavian king of Vikings, the pirates, and he lived in around I think 800 or 900 before 10th century. But what happened was that he was the king and he moved around so freely around Europe. So when they had new devices that was very freely moving around, and then they decided to give his name. It's a Dutch or those are the Norwegian name, those pirates of the Vikings. So anyway, that's a name where the name the Bluetooth comes from. But there's nothing like a Bluetooth network, but it's used as the connection close range. So that's actually belonging to PAN. But let's go to the near me area network. So NAN, near me area network, is a collective devices. So typically it is within a house. So in the house or in the office. So the office may be better, the analogy, the better situation. So you have a Wi-Fi, of course, and you have a direct connection, and there's a printer somewhere, but it's wirelessly connected or wired connection, and there is a certain other devices that they are checking on, and your security camera or connected and or interchangeable and accessible. This collective device is connected closer to me, such as home, office, or shop. That is called the near me area network. So in here, that there are many devices, but typically there's usually is a wireless and some wired. So the wired is called separate NAN because the software, the control program to handle those multiple the components of the equipments, and that combines into the communication system is going to be controlled by certain software that is quite different from internet or local area network. So it's a near me area network. Is some other different kind of a software. Then personal area network is that the PAN. So it is for personal usage. It's only me, just me using. So for example, you can tell me that where the Bluetooth is used. That's your wireless, the MP3 player. Your when you are listening to music, but without bothering others. Usually you can do by wired the earphone, but Bluetooth is typically used. Or you want to have some place and let it go to the speaker in a nearby system, so that it is just for you. The music typically is for your personal listening rather than everybody does. Then also your computer, when many of these days that, for example, your laptop has a Bluetooth mouse. So the mouse is for your computer. If while you are using your Bluetooth mouse, then your friend in the next desk whose screen is also moving, you don't like that, or he wouldn't like it. So that's the idea about those personal equipments, and they are connected. And then ILD, infrared data access. So that is ILDA. That's what you have up there, infrared given connection. And the ZigBee is another, the similar the devices that used frequently for personal usage, not as popular as Bluetooth. Then there's a wireless body area network. That is that you have something to wear. So actually the Bluetooth, mouse or the speaker is one of them, looks like, but at the same time that there's more wearables. So I don't know whether you have that smartwatch. I have one of those smartwatch from Samsung that has also the connection, but it's not Bluetooth. It is not the infrared, but rather its own connectivity. So when those objects that I'm wearing on my body that being used, then of course that if you are a special kind of job, like your police or the firefighters, then you need a bunch of equipments that need communicating, talking, and pilots that need a bunch of those devices working for you while you are doing your job. So those things, those need some kind of a network, and just for you. So if the personal area, then the people sitting next to you maybe have some affected, they can be sharing some data, but this is for your body only. Then near field communication, NFC. Maybe some of the laptop has NFC connector. So it is more like one computer to another computer, or one device like your cell phone, and download your phone, your photo, your picture from your phone to the laptop, or vice versa, that it can be done. So it is an electronic device within 4 centimeters, like that one. Now Bluetooth typically is within like a 10 meter of a range. It depends. Some of them are a little longer, the longer range. Some are much shorter, but about the 10 meter is what the Bluetooth. Then there's NFC. Near field is much closer, about 4 centimeter. Then nanoscale, the communication is it doesn't even have the name of AN yet, and the same thing with the near field is the nanoscale. It's a very low. 1 nano is actually meter. 1 nanometer is 1 billionth of a meter. So very near close. So nanotechnology you heard about. So nanotechnology is a very small scale of those communication about your bloodstream and your some of those molecular operator and some very special kind of equipment, including the quantum computers. Then they need communication and some kind of networking. So that's the nanoscale. So those things are not in the book, and may not. Those things, majority of this name of NAN, PAN, the band, and this is something that may be new to you, but this is the kind of new developments, and in the 4th generation industrial revolution, and where everything is super connectivity, that these are very important type of the networks. So there are a few of the pictures. So here, this is a twisted pair. I don't know whether you can see well or not, but this one, this UTP and STP. U is unshielded and STP is shielded. So TP, of course, is a twisted pair. So you see, each of them has 2 lines, 2 wires twisted so that they can be given with the same group. Because in one wire, there are many pairs of different connection to make. So you would like to make sure that this is paired, this is paired, this is paired. You need the connection to get any data communicated. So then in the case the typical, this is cheaper, of course, unshielded is cheaper. So you just pack many of those pairs of those shielded pairs of those twisted pair in one big cable. But sometimes that these wires go onto the tube called conduits, the underground, and that not only there's this kind of a data line or telephone line, sometimes a high-powered wire, whether the high voltage electricity or some fiber, optic fiber lines. There are so many different things that can be there. So they can interfere with those the electronic noises, or in a way the voltages. So there's the one that has a shielded. So sometimes you cut open this this cable. Then there's like a aluminum foil type of things that wound around it. Sometimes that they have each of those pairs being also shielded. So it's a little more expensive, but it does not get any kind of interference with the other types of devices or other types of lines, wires. So it's much clean data. Sometimes the noise is terrible. So that's the twisted pair. And then the typical one, this one is coaxial. So what it is that this is one conductor, usually negative, and there's a conductive. So there's some kind of plug it in. So the like a cable, TV, or the typical TV lines are using this kind of form. In computer, this is also actually is a twisted pair, but actually there's the 8 lines going in here into those Ethernet cable. So Ethernet is one protocol of LAN. So one most popular form of the protocol or the standards for the using those connection. So there's an Ethernet cable, and there's 8 connections here, so you plug it in. And then there's coaxial. This is a fiber optics. So this is a line. This is a single line, but it goes actually what it is a blinking, blinking, blinking. So there's a, by blinking means that there's a light coming up and stop or dark and on again, on again. So throughout the whole time, that by those blinking session of sometimes on and sometimes off, you have the 0, 1, 0, 1. So in here you need the wire to get the communication. Here one is good enough of going sending those data and the receiving the same line, because it is a different wave, so they can handle that. This one is I didn't put much, but this is RFID, radio frequency ID. So in a way that when you have some they check out the stand there, when you some device or you pass through those reader, then it gives sometimes blinks or sometimes just passing it through. Or in the supermarket checkout, and there's a little bit of those. It's more like an antenna and with a little. Some of them has own power, but most of them is a passive, so no power. But it is a reader is sending some signal, and it reflects, and that reflect back and see that what kind of product it is and where it is. So it goes a certain range of the operation. So this range usually is kind of the near me or those kind of things. So it goes usually within checkout account. So there's a nearby area you pass through. So when you buy a lot of groceries, each one has some kind of those RFID, the marker or this receiver, and you just put out this cart. Then in the checkout stand, they are reading it. So without going one at a time, it goes, and everybody, every item got read through. Then when you are counting money, you got a whole thick number of the money. Some are $1 bill, $5 bill, the $20 bill, the $10 bill, like that. So each one later on that have a little dots of those sensor of those RFID. Then you just pass through. Then every sensor got some kind of response, and you end up just counting it without counting it or going through any kind of machine. That's just passing through, and you can count on it. Then here's a Bluetooth. This one is a Bluetooth symbol, you know, that there's a B here, and then this K is more about the receiver kind of meaning. So from this, kind of earphone, earpad, or the speaker, or your phone, or the TV, or the computer screen, that you can interact. Then this is IR, so infrared, the way it is that by going through the infrared, and typically barcode, or these days is a QR code. QR code is a quick response code. So the quick response code is very popular these days, because the barcode can typically store those barcode store the just one number, one set of numbers of say the 10 digits or 12 digits, or sometimes there are 4 digits, like that very small amount of data. But QR code is two-dimensional, so you can get several thousand bytes of that data, so it's more useful. Anyway, so that's read through infrared, and this is a microwave the dish. So those are low, the high frequency and the short wave type of those signals going in and out. So actually, micro is shorter, even shorter than short wave. So it is very high energy there, and it's going farther away, and usually interconnects to another station. Then, of course, that here is a satellite, so they circle around the Earth. When they are launching that, I think it's the 40,000 meter. So 40,000 meter, 4 kilometer, somewhere. They on the air. If it's the Earth here, and there's a certain orbit, then if at that certain the height, then the speed of moving and the Earth moving is exactly the same. So in a sense, from the Earth, that satellite looks stationary, because they are spinning with the same speed as Earth rotation. So from the standpoint of standing on from the one point in the Earth, that goes just the whole same location all the time. So it is very stable connection. Some of the important terminologies. So protocol, I was talking about. So protocol is more of a diplomatic terms. So one ambassador, say French ambassador to US, came to Washington and present. Then there's a thing called a protocol. Protocol is more of a rule and then convention of the standard, so that any manufacturer can create the devices that will fit and work together. That's how all those devices are made by thousands of different companies, still working just fine. That's how it goes. This is talking about packet switching. Then TCP/IP, that's Transfer Control Protocol, and Internet Protocol. This is the way our internet that you were using day after day is being used. They are layered, like application layer, transport, internet, and the network layers. So this one takes this whole thing, or whatever I'm talking today, takes more than a semester of the subjects. But I'm just giving some kind of the overviews. So originally open the system, the initiative. So that's a 7-layer model had something, but they thought that's too complicated, so they decided to have only 4 layers. So that's how the TCP/IP is being used for our internet. So there's a certain standard that follow through. Do you have to know it? Well, you don't have to, but there is always based on certain standards. And who's controlling those standards? There's IEEE, IEEE, International Institute of Electrical and the Electrical and Electronic Engineers group like that one. So they a lot of scholars, they are making the standard. When they are talking about the bandwidth, is that how fast is the signal. Bandwidth originally meant to be how broad is the road. So highway, when there's only one, the road has only one lane, it's going to be very slow, even if there's no traffic accident. 2, it'll be much better. 3, 4, if it's an 8-lane big freeway, then data will go very fast. So that's the name given, the bandwidth, the width of those band of those data moving. So by so anyway, the higher is the bandwidth, then its speed is faster. You can get more data within amount of time. So measured by bits per second. This one goes by serial, so it doesn't go by bytes, but it's a 0, 1, 0, 1, 0, 1 going in a long stream. So that stream is bits per second, so BPS. But of course, 1 BPS is so small, so we have a kilo BPS, 1,000 the bits per second, mega BPS, giga, and tera BPS like that. So kilo is 1,000, mega is a million, giga is a billion, T is a trillion. It's 1,000 giga, so much faster. Those things are modern connection measures in by giga. And then VPN, virtual private network. This is something to do with some security issues, but there may be some hacking or there's some kind of danger of somebody coming in. So if you are making this network, it's shared, of course. That's why there is a word called the bus. Bus is that a road where multiple data can be sharing together, but one at a time. That's the key. So when there's a collision, there are too many going at the same time, they got to set the order and the way. So anyway, the bus goes on one direction and another direction like that. But the bus is the data line shared. That's what it means. So the network is actually shared, or the network area is shared, but you want to have your security. So there's a certain special ID and the special the checking points to make sure that you are using it, no one else will just jump in. That's a virtual private network, so VPN. Virtual means it's not really you are owning it, but looks like you're owning. That's what the VPN, the name comes from. Let's look at Wi-Fi network. This one is a part of a LAN, but mostly it is for the understanding is a NAN, near my location, near me location. So anyway, it is the Wi-Fi, and what that Wi-Fi stands for. That's actually wireless fidelity. What does that mean? Fidelity is a confidence or faithful. That's the idea about the fidelity. Older days, maybe you heard about the stereo fidelity. So when there's a device is having wonderful stereo music, that's the sound reproduction from that the system is as good as a real concert or real music. That's the idea about the fidelity, faithful, as good as a real thing. So what is the real thing? That's a wired one. Actually, wired connection is much faster, and it is more higher quality connection. So it's much better. But in here, so when you make it wireless, then is it good enough? Yes, we'll make it as if you won't tell the difference whether this is wired or wireless. That's the Wi-Fi, so the name comes from. And you need a good equipment for that. So that equipment, first thing is a router, things like that. There are hundreds of different kinds, but this is one of them. And then what it is that they are either from wired line, that's most typical one, or from other wireless, the router, you just they accept that. Then you will rebroadcast those the internet the signal to people. But why is called the router? Route means that different route, isn't it? So suppose there are let's say 10 people using the same Wi-Fi. By the way, each Wi-Fi, what you have at home, has a limits. So usually if it's more than 16 people, or even more than 6 people, that the bandwidth is reducing because the same one line and everybody using it, so it gets slow, or sometimes it doesn't even allow you to join. So there is a certain limitation, but in terms of once connected, then the quality is supposed to be same as wired. That's what the fidelity is for. So anyway, router means that you have a connection, you have connection. Then this machine knows that a kind of communication, that this person is connected to Google, the searching, and this one is Wikipedia, this one person doing some kind of programming using some kind of units, this person doing SNS or something. So this different kind of access and different operation, it is knowing that where each signal belonging to. So that's the routing. So it's going a different path. It is the opening for. Then there's another. There are several type of other devices related. One is that the modem. Modem is that typical internet line, or those signal comes from the coaxial cable, as we have seen, or the coaxial, that's for the twisted line, that's for the telephone, and the coaxial for those from cable company, or somehow that can, so cable company and some other dish. So they are coming in certain way as a analog. So you got to convert that one to digital. That's what the modem is doing. So modulator, demodulator is what the name. Then repeater is the kind of thing that if the signal is getting weaker because of the range, the power depends on how much of it can reach. So it go around in here. Then you see those lines getting, a number of those lines getting fading smaller. Then you can have another one set it up and rebroadcast. Then within a house, if you have a relatively larger house, then you in the repeaters around it. Some people call that the amplifier. Then there's a bridge. The bridge is that between one type of unit to another type that you can make a connection. Hub is that you have a different signal that coming into connectivity, and the switch is the one that changes from one unit, one device to another device. So there are differences in those devices, and then the IEEE has different standard for Wi-Fi model. So 802.11, that is what the Wi-Fi is for, and there's A, B, G, and AC like that. And there's a range. It's indoor is shorter. The range of this reaching is shorter for the indoor because there's walls and many obstacles. Outdoor is much the longer range. So it's roughly, usually we say depends, but about 3 feet is you divide by 3, then that's about those number of meters. So this is close to like 300 meter, and this one is about 200 meters, so like that one. Then the speed is somehow most of the A, B, G, these things are 50, 11, this kind of thing. Then N is very fast. So when you are buying this router, then the routers are not all equal, and then AC is so far the best in a sense, as the range is top and 1.3 gigabits, so much faster, that kind of thing. So just knowing the name and the terminology is something you will have to. Then cell phone. Wasn't it the kind of curious why it's called a cell phone? What is a cell? A cell is the jail, or is our body cell? What is it? Yeah, it is cell. Actually, it's a cellular. So it's like a cell. So what it is that your wireless telephone, your telephone is of course wireless. If you're carrying your personal phone and it's all wired, it's gonna be big trouble, unusable. So it should be used without any wire connection. Then, among others, your phone has a battery that's very small and has a power very limited, so it cannot go forever. Like a radio signal, suppose that you are tuning into the radio, then you can listen to the radio station very far away, because they are sending very strong signal. But in the cell phone, you got to not only you receive it, but you must also send. You talk, then it must go to your partner's phone. That must be the hearing or the connected. So what it is the whole geographic area is subdivided into smaller subunits. So this one is called the cell. So it looks like, doesn't it look like a cell? Body cell. So there's a certain area depending on the area and the existence of the building or those obstacles, plus number of users and so on, and usually more of the distances, that they have the area segmented somehow differently. But there's one tower. The tower looks like way out there. So there's some microwave and this 2G, 3G, 4G all together like that. So what it is that you are sitting in here and talking, then you are using the nearest tower. Then tower that you are calling your friend whose number is 41736. There's actually, this is connected also to base station, so they know. So your friend at the other number who happens to be in here, then it is connecting, but you cannot reach directly. So this tower will transmit your signal over here, and that tower will connect to your friend. So you are talking this way. This person is moving in here, then say, this is out. Then he will be reconnected to another tower, and then that tower will directly or indirectly be connected. So maybe the tower, maybe way out here, then it is going through sometimes connection or sometimes directly to that tower it is being connected. So that's the idea about the cellular phone. So mobile network it is called. So here's the main tower here, and they got a base station. So every time that you see those station, when you look around, and there's another small building with a lot of noise and high voltage, because they are producing huge amount of electricity to convert into the power of waves and so on. Then there's a main phone company or main line. There all those numbers look up and where your friend is, they are checking. So this kind of mobile network is pretty much well established. So you are using it without thinking, but it is a collection of a great technology. This one is somewhat inaccurate. I just compiled some of those numbers, but you heard about the 5G, and then there's a zero generation, first generation. First, this two generations is analog. It is really the converting your voice into some kind of wave and sending it over. So your voice is much like that, directly talking. So the range was limited, and the number of people who can use the phone at the same time was limited, and this the range was, and the sound quality wasn't good like that one. So we are talking about the around the 60s. There's all the radio phone, telephone, but it is not much of the mobile phone. And then 81. So maybe you may remember that the telephone around this time is as big as a brick, huge. So very heavy because they need a huge battery, but not anymore. It's very efficient now. So in second generation, so G, that's where all the G is coming from. 0G, 1G, 2G, 3G, 4G, 5G. You don't hear much of 1G, 2G, but still there's formal terms. And right now that we are in 4G, and started 5G in 2020s. So the fifth generation new radio, that's what they call the radio. Then the long-term, the extension, something like that, I forgot, sorry. So there's the fourth generation has a LTE protocol, and then it allows internet freely. So there's a whole bunch, and the CDMA, there's a code division and multiple access or something like that. So as the acronyms. So there's a different speeds in here. So we haven't got much of a 5G, let alone 6G, but 6G maybe, so I got a lot of question mark. The 2025 maybe showing up, or maybe even later. Then and also that right now the 5G, that one still has a 144. I mean the 14 meg, something like that, very low. But the 144, I think 144 is what they released it, but eventually it'll go to 1 gigabits. But this 6G will be IoT, so it's Internet of Things and AI, and they will design the special chip for the circuit, so it's going to be very expensive until it is being sold by mass. So it can promise or predicts 3 terabits. So I don't know what we're going to do with the 3 terabits of speed, but it's going to be very, very fast. That's what we are expecting. Okay, then the chapter 9 talks about what you do with this wonderful setup of the connection. So instant messaging, so email and short message services and social networking. In many countries that is called SNS. But in America, that they don't call it SNS, but just a social network. And the blogs and the micro blogs and the news groups and the Wikipedia. Wiki is the kind of everybody contributing. So the Wikipedia is a good example, but there are many other wikis that the people are contributing to the contents. And if there's any error or something they need update or they improve, then they can contribute. So user contributed contents forum, there's certain discussion issues they talk together and discuss it. And then the web pages, of course. Hopefully that you have some web page of your own. I used to have one, but I'm not using it anymore. But as a personalized website. And then WordPress is the software. Wix is the company that provides those very easy to use website builder. WordPress isn't that bad, it is easy to. Then Dreamweaver is the original one, is from Adobe, and the little difficult and a little expensive, and used to be a very popular one though, but not anymore in a sense. Then voice over IP, that you give using internet. Why don't we make why have a separate line for internet and then this cellular phone? So rather use this internet connection for like a telephone connections. And the video chatting, just like what we do on the Zoom or FaceTime, Skype, those kind of things are actually the video chatting. So these are all the wonderful communication you do. Then email, among them is most important or frequently used. Maybe this is getting outdated, that the social media or social the networking is getting more popular and faster and speedier for the responses. But old mail is called snail mail, so slow. Then there are a few of those protocols. Again, I don't have time because I'm running out of time, but these are the kind of terms you are seeing when dealing with email. But there are quite a few different forms of the email being governed and maintained. And then there are so this is a kind of diagram that what is involved in sending and receiving this email. So there is a mail user agent, it's an agent, and then mail sending and the transmitting. Your sender, they gives a different conversion of the format, and transmitting over the air or some internet lines. And then it is again MTA transmission, mail transmission agent, that goes into mail delivery agent. Then user agent will see that one. So the reason I'm just putting this one, this is for the network class, but I have given those word PA by map, SMTP. There's a simple mail transfer protocol, that kind of a thing. So just saying it is being used somewhere, or rather, mail utility is very complicated. And then few of those negative terms, I'm just gonna show you only without explaining much, except to say the spamming you heard about. The spam is the kind of the canned food that with those bunch of those meat. And that one time in England that there were so many spams given by U.S. Troops or military, so they thought, oh, that's too much. So when mail comes with so many things together, then the U.S. says, oh, it's a spam. That's it. Phishing is the another spelling difference of phishing. So you just hooking you into doing something and fall into scams like that. And the farming is directing your website to some other places. So these are some negative terms, and they even making some kind of a special terminology. So it pronounces the same, but the actually meaning is different. That's what it means. So smithing is SMS phishing. So using your the social network like the Twitter or the Katalog or the Facebook, then just luring you into some illegal action or giving you personal information so that they can jump into your bank accounts, things like that. So conclusion, modern cyber system has a higher level of connectivity. So super connectivity is the thing. Everything is connected. I didn't get a chance to talk about IoT. There's the Internet of Things. Everything you see, they just look around, and then all the cups and clock, book, and your equipments, and your shoes, and your chair, furniture, those things, each individual thing, each item, thing, can have its own internet address and be communicated. So of course that for most of them, the best usage may be inventory checking, but more importantly, it can be used for your movement or your behavior, your health monitors like that. So anyhow, it's amazing how much of those advances came up, and there's different level of connectivity. So from internet to nanoscale, there's a huge range from all world together. I said that interplanetary the network also to just a nanoscale, the invisible, so small, like a virus size. The distance is big, all connected, and then you need the different equipment for different level of connection. And then software-wise, that you can use so many, so including websites and email and social networks. And in the future, that closer and personalized connection will be prevailing. So every item, especially like IoT, that every item you have and any thing you own and you are using it, like cars and your the devices, electronic devices, those things are all connected and you can control, including smart home idea that you can control every equipment from outside, and there's a smart farm or city where everything, traffic and our daily living and transportation can be controlled. So that's all. I'm sorry that I went a little over time, and even that, and I feel like, oh, I really scratched the surface of this huge subject of the connectivity. This networking is something that you put is a major, that there is a major just doing these subjects all 4 years of college and at graduate school. So anyway, this is the part of the lesson number 7 or week 7 class lecture. And have a good day, and we'll talk about the security and the ethical social issues next time. Bye.